The Downfall and Recovery of Point Pleasant Park's Forest Ecology Following Hurricane Juan by Tasha, Mackenzie, and Cameron. Hurricane Juan was a Category 2 hurricane that occurred on September 28, 2003. It was the worst storm seen in more than a century, with winds sustained at up to 151 kilometers per hour. Unfortunately, because of its severity, not only did it destroy 300,000 homes and businesses, it completely decimated the ecology of the beloved Point Pleasant Park, killing more than 70% of its trees. Point Pleasant Park is a staple in the Halifax community, especially to the Mi'kmaq people. This park was traditionally known as Amnukati, meaning spiritual place, or the place of the spirits. The Mi'kmaq believed the Great Spirit Fire sat in the Amnukati, and that its spark gave birth to the original 7 Mi'kmaq families. Point Pleasant Park was a traditional gathering place of the Mi'kmaq. It also, being so close to the water, historically played a role in their travel and trade networks along the coast, and was a place used for hunting, fishing, and gathering. The forest of Point Pleasant Park is classified as a spruce, fir, pine, maple, birch association, with red spruce and white pine being the most dominant. It was classified as a mature Acadian forest with a stable ecosystem. After Hurricane Juan, the park suffered a major ecological shift, and areas that were once flush with red spruce now barely had any, favoring other species such as red maple and white birch. This ecological shift was also seen in many other forests following the hurricane, with the storm creating conditions that favored these faster-growing species of red maple and white birch. The measures used to interpret the data we will be using today regarding Point Pleasant Park include species diversity using the Shannon Diversity Index, which accounts for the number of different species through the proportion of a species abundance relative to the total abundance of all species in that community, while also taking into account evenness. Pugh's Evenness Index looks at how evenly distributed each species within a community is, and ranges from 0 to 1, with 1 being the most even an area can be. This study looks at the secondary succession of Point Pleasant Park following Hurricane Juan, using total species richness, diversity, and evenness to look at shifts in dominant species, changes in density over time, and progression towards a new community climax. Succession refers to a gradual change in an ecological community following a disturbance, and more specifically, a secondary succession involves a disturbance that does not cover, remove, or create new substrates, like Hurricane Juan. Our objective for this study was to evaluate the effects Hurricane Juan had on Point Pleasant Park over time, and to study the secondary succession of Point Pleasant Park following that disturbance. The first question we wanted to investigate was how the overall forest community had changed over time and why. And what can we predict will happen to the overall community as the forest moved towards its climax community and why? Our hypothesis was that the total vegetation and forest density of Point Pleasant Park has increased since the initial disturbance of Hurricane Juan in 2003. And our null was that the total vegetation and forest density of Point Pleasant Park has not increased nor decreased since the initial disturbance of Hurricane Juan in 2003.
This slide was unable to get done as one of the members of our group wasn't present. Question 3 of the study asks how is the species richness within Point Pleasant Park changed over time and why, as well as what can you predict will happen to the species richness as the forest moves towards its climax community and why. Our prediction for this question states that the species richness of Point Pleasant Park has increased since the initial disturbance of Hurricane Juan in 2003. Our null hypothesis for this question states that the species richness of Point Pleasant Park has not increased nor decreased since the initial disturbance of Hurricane Juan in 2003. To analyze secondary succession at Point Pleasant Park, researchers collected the tree density per species from the same 5 species within the park once a year over the years of 2004 to 2024. The 5 sites in this study were chosen as they were the 5 most impacted sites after Hurricane Juan. After researchers had collected the appropriate data, it was placed into Excel and the total tree density, the density of red spruce, the density of red maple, and the species richness at each site for each year of the study was calculated. Furthermore, scatter plots containing a regression line were made from each of the datasets using Excel. A regression analysis was applied to the graphs to determine the equation of the line, r squared, the f statistic, and the p-value of the data.
Based on the data collected, a linear regression analysis was performed of the average total tree density in Point Pleasant Park measured in quadrant 400 meters squared following the subsequent years of Hurricane Juan. Note that the figure shows total density between 2000 and 2025, while actual data was collected from 2004 to 2023, disregarding the years 2005, 2016, and 2020. The total tree density refers to the density per species of trees per 400 meters squared in selected quadrants. Immediately following Hurricane Juan, tree density was extremely low, with many plots showing hardly any regrowth, as seen on Figure 3. However, in recent years, tree growth has accelerated, with some plots seeing over 200 trees per quadrant. The graph shows an R-squared value of 0.4926, and that, along with the positive relationship seen between tree density and time, allows us to conclude that the forest is increasing in total tree density, and reject our null hypothesis that total tree density following the hurricane has not increased nor decreased over time. The regression model shows a consistent increase of said tree density of Point Pleasant Park following the years of Hurricane Juan, excluding any outliers, with numbers directly after the hurricane in 2005 ranging from 0 to 10, to today, ranging anywhere between 50 and 200 trees per quadrant. This consistent and steady regrowth following damages sustained by wind is consistent with other studies, such as the one done by Harmon and Pabst in 2019, with the number of trees per plot also increasing steadily following wind damage. From the positive density dependence of our model and the predicted continuance of Point Pleasant Park's secondary succession, we can predict that the climax community will not only be achieved but will flourish, where we'll see an increase in biodiversity, a more sustainable growth pattern that will level off at some point in the future, and a decline in more short-lived species per quadrant, such as birch and polar, as they are outcompeted by longer-living yet slower-growing species like oak and red spruce, which originally dominated Point Pleasant Park before the hurricane. As a note, a linear regression model was used to quantify the pattern of total tree density related to the subsequent years, and provides a statistical outcome based on actual observations, and determines if tree density was statistically meaningful.
The next 3 slides were unable to get done as one of the members in our group wasn't present. Linear regression was used to examine the species richness of 5 different sites over the years of 2004 to 2024 at Point Pleasant Park. The results of the linear regression analysis, as can be seen on the slide, indicated there was a clear positive relationship between species richness and year. As well, the results indicated there was a strong relationship between species richness and year. The p-value determined in the linear regression analysis was below 0.05 and therefore indicated that the null hypothesis can be rejected. The statistical results of the study, as well as the null hypothesis being rejected, indicated that over the time frame of the study, the species richness of trees within the Point Pleasant area has grown. In Figure 8, we see the forest right after Hurricane Juan. There are many trees fallen and it looks quite lifeless, and there is a visibly low species richness. In Figure 9, we now can see the forest in 2022, 19 years after the hurricane, looking very replenished, and a large part of this growth is in species richness. This visible growth has occurred due to the increase in resource availability that follows a secondary successional event, in our case, Hurricane Juan. The high levels of resource availability allow species to repopulate the area at rapid speeds, as well as allowing new species to populate within the area. However, resources only last for so long, and so as the forest moves towards its climax community, species richness may decrease within the population due to the decrease in resource availability. This decrease will cause a slowdown and possibly a halt in species richness within the area. Based on the results of this study and other research, it is predicted that the Point Pleasant Park forest is in a mid-succession stage. While urban forests experience unique disturbances, studies suggest that Point Pleasant Park does not require human intervention to repopulate after Hurricane Juan. In mid-successional forests, specific vegetation types are expected and suggest the forest successional stage, such as the red maple. In 2024, red maple trees were recorded as the dominant species in Point Pleasant Park, exhibiting a high density. These forests typically have dominant tree species with shorter lifespans than those in later successional stages. Red maples live for 80 to 130 years, whereas red spruce, which dominated Point Pleasant Park before Hurricane Juan, can live for 250 to 350 years, significantly longer than the red maple. As well, species richness generally increases during early to mid successional stages within a forest. Over the years of this study, species richness in Point Pleasant Park has increased, further supporting its classification as a mid-succession forest. Although urban influences did not seem to significantly impact Point Pleasant Park, certain factors such as trail systems may still affect its progression towards a mature Acadian forest. Wide trails negatively impact adjacent vegetation, especially when they pass through sensitive areas. To mitigate this, trails should be narrower and avoid high-density or ecologically fragile regions within the park. Additionally, incorporating Indigenous perspectives through two-eyed seeing, viewing the world through both Indigenous and Western knowledge systems, can provide a broader, more effective approach to forest management. While secondary succession poses challenges for forests, minimal intervention is often the best approach for natural restoration.
We'd like to thank and acknowledge Dr. Allison Schmidt for her continuous guidance throughout the project, and the previous classes who collected the data we used from Point Pleasant Park. Without Dr. Schmidt's kindness and eagerness to help both in and out of the lab, this project would not have been possible. Thank you.
Here are the references used within our study.